much for coming. My name is Andres, for those who don't know me. I am the co-founder of Terralynx. We used to be Terranova UAV, but now we've transformed. We're more into the data collection, the analysis, aerial imagery, all those things. It's not so much about the drones anymore, it's what you can do with them and how you create value with them, all right? So the idea today is to talk about technology, to geek out a little bit, to go and talk about what's new, what's happening with artificial intelligence, how it's being applied, a few of the concepts about what we do, right? So that is the purpose here. Now, we're gonna get this out of the way. We create maps using drones. We use multispectral imagery and we use Lidar for that. Multispectral imagery, we will explain that in a little bit, but that we charge approximately $7 an acre, starting at $7 an acre, and with Lidar, it's approximately $1,000 an hour, right? I just want to get that out of the way in case you guys are wondering, but we are going to start talking about these very specific concepts about vegetation indices, about what is happening with drone technology. We're going to be talking about like spraying with drones, where that is right now, and at the end, we will do a quick demo with this drone. We're going to be doing a 3D map or a 3D model of the plot that you have behind you. Okay, so let's get started. So what are the technologies that we are currently using, or that we mostly use at Terralynx? The first one is, I'm going to start from the bottom with multispectral imagery. So who here is familiarized with NDVI, vegetation indices, multispectral imagery? Okay, we have a few, all right? It's always good to have a quick refresher about these techniques, these technologies, or this imagery, so we're all in context. Now, multispectral imagery means it can be done with satellites, it can be done with these type of drones, with any type of sensor, but basically, when plants feel stress, and let me just go here, oh, this other one. When plants feel stress, when plants actually receive light from the sun, they reflect different bandwidths or different, wavelengths, which make the plants look the way that they do. The reason why they're green, the reason why they change colors when they feel stress, right? In the green, red, blue areas of the spectrum. But they also, what they receive from the sun, they also reflect a couple of other bands that are called red edge and near infrared. Now those last bands, the red edge and the near infrared, we can't detect them. Now, if a plant is feeling stress for some reason, if there's a nutrient deficiency, if there's a pest, if there's a disease, if it's feeling any type of stress, the plant will start changing the way that it reflects on this near infrared, right? But you can't see it yet. You can't see it with your bare eyes. So that's why we have these type of sensors that pick up on those signals, and then we can create maps, which we then turn into calculations, which tell you about the health of the plant, whether a plant is healthier in certain ways than others, or if it has a better nitrogen uptake than others. That's how vegetation indices work. These are calculations that you use based on what these readings from these sensors tell you, and that is turned into different maps. They can turn into management zones, into prescription maps, which we will see in a second. And now the other technology that we're currently using is Lidar, or lasers, basically, and that's what that big guy does there. So what that drone does is, or what that sensor does is, it shoots lasers 240,000 times per second. And what the sensor does is, it calculates the time that it takes for the laser to hit the ground or hit the plant and then come back. And then it does the calculation with the speed of light, and it gives it an exact distance to each of these dots. Now the results of that is a 3D model, what it's called a point cloud, because you get a bunch of points that are building across a certain distance, and then you end up with these types of models. How is that helpful? Why is this important, doing or using these types of technologies? So multispectral imagery helps us with diagnosing, with even detecting tile drainage lines, existing tile drainage lines, because the plants respond differently. For scouting, I mean, there are different uses of different types of vegetation, and this is using multispectral imagery. And the second one, with laser, or with Lidar, you can get very highly detailed topographic models of fields, not just the fields, but also the plants. That way you can calculate biomass. You can correlate the 3D model with different types of soil. You can help, it also helps with the design and the construction of tile lines. You can detect any water issues. There are a lot of different applications for LiDAR as well. And with that, I can give you a few examples of some of the work that we did this year, or some of these applications of these technologies. So the first one that you see here on the top left, and I don't know if you guys can see it, you're a little bit far, but anyway, so basically the one at the top left, we used a high resolution camera drone. We flew it really close to the plants, and we used artificial intelligence to count individual plants. So with artificial intelligence, basically what you do is you tell it, okay, this looks like a plant, and you give it an example. This looks like a plant. This other thing looks like a plant, like 3 corn plants. Now go on and count the rest based on what I just showed you. And it did, and it counts millions of plants across entire fields. Now, what the model will tell you, the first thing that it will say is, okay, well, you have 1 million plants on this field. Yeah, so what? What does it mean to have 1 million plants on a field? It means nothing, right? Until you start breaking it down and until you start analyzing it. So what is it that we did with that model where it selected every individual plant? We turned it into a grid, and we created a grid of 40 foot by 40 foot, 40 feet by 40 feet cells, which so happened to be, because this one was for a client that had a 120 feet wide boom for her sprayer, so she wanted to break it down into 3 different zones. So we created these cells of 40 foot wide each. So that's how she could put it into her John Deere Op Center, and then she could do a variable nitrogen application based off the vegetation density or the plant density on each of these cells that we calculated. So that was a really interesting story to make the best use of nitrogen in this case. The one that you see on the top right is a fungicide application. It's an on-off fungicide application, which we put together based on the NDVI, or Normalized Difference Vegetation Index, based on multispectral imagery, in which the farmer basically, he had a sprayer, a variable sprayer, and he just turned on and off the nozzles based on the numbers, or based on this prescription map that we provided him. Now, I should mention here, you can do it with a regular sprayer, but you can also do it with a drone. Now, I'd like to hear who here has used drones for spraying, whatever it is. I'm not gonna ask. Who has used drones in their farms for spraying? How was the experience?
Awesome.
It's good, right? It's coming. Yeah, spraying with drones. The sprayer drones are a great technology, right? And it's coming. There are regulatory changes that still need to happen, like the weight of the drone, permits, whether you can, spray pesticide. The U.S. is way ahead of us in that regards. Canada is just catching up, and it's happening, right? It's going to happen. It's not a matter of if, it's a matter of when. Now, the other advantage of these drones, what's the main advantage that you saw from spraying with the drone?
You get for spot spraying applications, instead of running your rig across the whole field, you just go out and hit the different spots of the field with no tramping.
Excellent. Thank you. Thank you again. Yes. So that it's a great example of the applications of spraying with drones. Now, as you said, with spot spraying, which can also be done with variable spraying, basically what we do is we feed those sprayer drones, or a regular sprayer, with these maps, and the drone can know exactly where to spray, or it will change the rate at which it sprays or at which it spreads in case of a cedar drone, right? So those are 2 really interesting applications of this imagery applied into spraying or seeding with drones. The one at the bottom right is Now we're also working with conservation authorities and also with livestock management into mapping methane. This is methane mapping, so we're taking samples of methane gas from manure pits in order to get a very good idea of greenhouse gas emissions, especially methane. And the one here at the bottom left, that one is also interesting because this was the work that we did in partnership with a drainage company, with La Pointe Drainage. And basically by putting together these 3D models of a field, even with standing plants, with standing corn, we can put together the model of the ground below, and then we can do a 3D model, which then turns into the design for an underground tiling system. So those are, some of those stories. This is the example of the underground tiling system that we did with them. So that's a 3D model of the field that we put together with the drone, which you will see in a second, creating a 3D model in real time. There's the analysis where you can see the height of the trees, the height of the land. The other advantage of the laser is because it penetrates through the plants. You can see the trees now. Now you don't. So you can remove all of that, you can filter it all out, and then with the bare ground, you can run all sorts of different analysis. You can do profile analysis, you can check the slopes, you can check distances. And then you can export it into software such as Trimble Ag to create your tile design with that. So these are some really, really interesting applications that we have had the opportunity to use our technology with. Now, before I do the demo, how much time do we have left? About 10 minutes?
5 to. We have some time.
Okay, good, excellent. So what I'd like to do now is let's talk about the new technologies that are out there, the technologies that are transforming our lives. I can think of 3 that are transforming us. One of them is robotics. Drones are part of that, robotics in general. The second one is AI, artificial intelligence. The third one is quantum computing, but that's another concept that we can leave for later. So let's just focus on robotics. We just talked about that a bit ago. And now let's talk about AI. Now, let's do a quick show of hands here. Who here has used artificial intelligence, call it ChatGPT, Grok, any of those models for their farming operation? Peter, would you like to share a bit more?
Well, we all use it. Every time you use the web, you go on and you ask it a question about sudden death syndrome in soybeans, and the first thing that comes up is AI generated, and it gives you that answer. So everybody here doesn't think they've used it, but everybody in this group probably has.
That's a very good answer. Now, actively, there are 2 elements to that. The first one is AI is here. Yes, it's ubiquitous. Everyone is using it. So the next time I ask the question, especially next year, everyone should be raising their hand because it's here and it's part of it. It's not whether you use it or you don't. It's how you use it and how you take advantage of that. So that is the first element. The second element of that is artificial intelligence alone is no good. Like, it doesn't work because, as you may know, when you ask those questions, it will make mistakes. It's not 100% accurate. But imagine when you ask those questions, when you use, for example, ChatGPT, and you ask it a question, imagine like you had a PhD level advisor sitting in front of you, with access to all the available sources of information around the world, and it can give them to you right then and there. Like, how powerful is that? But that is just as powerful. It's only as powerful as you are with your own experience. You need your own criteria to take those advices, to take those texts, that data, and then apply it properly to your operation. And you will see how that can transform not just the operation, but in general. I mean, it's something that's mind-blowing, and it's something that I highly encourage. The message here is encouraging everyone to actively just use it and ask the questions, because that is what really will make us more competitive. It's staying ahead, and the tools are there to do it. All right, so that is one part. And I actually wanted to share some of the examples of how we have used artificial intelligence that I think are really cool. So let me just do a couple here. One was this one here. So this was the plant count, the one I told you about. So you see the plants here. And with this, we can not only count the plants, but we can get, for example, like the plant distance, like the spacing. We can, here are the counts. I don't know why they're not popping up. Oh, here we go. Here are the counts that I mentioned. The AI that detects which are the plants that's computer vision. The second example is this one here. So this is a field that we flew a few weeks ago. We did NDVI, multispectral imagery again, with this one. And then we asked NDVI to, we asked the AI to generate field insights. So basically it asked us, okay, so when was this field planted? And we said, okay, it was mid-April or end of April. It took all of the data from weather, the soil types, everything. It took it all into account, and it said, okay, at this stage, you have an NDVI and an average NDVI of 0.55, hence your health is doing good based on what you said on when you planted, based on these weather patterns. This is what you should be thinking about in terms of timing for harvesting and how to manage your crop. It did it all because it had all of that information that I had no idea about. All I knew was I mapped this field on this date. So very, very useful there. And the last one was one using just ChatGPT here. This one was interesting. Basically, oh, so this one was this right here. Let me just get it. So on this field, this was a trial where they had separated groups of 10 rows of corn, and they did different applications of nitrogen inhibitor and different rates of nitrogen on it. So basically, I had, at the first, they just gave me the map and they go like, okay, now analyze it. I had no idea what to make out of it. So I just took it, I created this grid with like different colors. But then what I did was, I just threw a table with a bunch of numbers, with a bunch of like all of these indices that the multispectral imagery gave me. I just threw it at ChatGPT. And I said, what do I do with this? So ChatGPT said, okay, now let's do an ANOVA statistical analysis to see if the values or if there is some statistically significant correlation between the different nitrogen treatments. Turns out it wasn't, because the p-value was below 0.497. It's really hard to understand all of that, and not even I understood it. Hadn't I used ChatGPT, I would have had no idea that this even existed, but it gave me the tools, enough tools, to come up with some crazy high-level answer for the client. So really, really useful, really interesting cases for uses of AI. All right, so we're gonna finish up, how much time? 10. All right. So we're just gonna finish up with a quick demo here of the drone. Basically what we'll be doing is we're gonna be flying this field here. We're gonna fly at 160 feet, and we're gonna create a 3D model in real time, and then we're gonna do some analytics on that to see, you know, what the advantages of this 3D imagery are. All right. So let me just turn this on here. Got enough battery for one, I think. And then we'll turn on this here. Did 527, that should be okay. All right, everyone can see the screen. Okay, it's just starting now. Okay, just go here. That's the map that we're gonna do. Nope. Things we're all connected. It seems like we're all good. All right. Let's get started. And we're ready to go in 3, 2, 1.
Moving to start point.
So we're gonna go 160 feet, and then the drone's just gonna start going back and forth in that direction. First, it's gonna start doing some calibration, which will take about 20 seconds. So let's take a look at the screen. So that's what the drone is seeing up front, and this is what it's seeing down below. So it's doing its calibration. That should take just a couple more seconds. And almost there. Last one. Now it's mapping. Now check this out. As it's flying, it's generating the 3D model very quickly here. No hands.
Does it have to be a certain amount of feet in the air?
Depends on the kind of precision that you need. But in general, we fly at 250 feet. This one is a little bit lower just for demonstration purposes, but it generates very similar kind of results between here and 250 feet. Now, okay, now it's doing this. Now we're just gonna let it come back home. It's almost done here. Yeah, it's pretty much done. So, in the interest of time, I will show you what this drone generated. Okay, now we can return it home. So, this is what the drone generated here. Check this out. This is the 3D model of the field, of the plot here, right? We're sitting approximately here. This is the model, but you can run all sorts of different analysis with this. You can run, for example, a profile. So let's run a profile here. And here you can pretty much see and measure. You can measure the height of the plants. You can measure how uniform a field is. Just let it land. Perfect. And then you can go as far as calculating, for example, the volume of vegetation there. So if I go here, I know that I have, on that plot, I have 750 cubic meters of biomass. So with that, we can run all sorts of different analysis, the uniformity, timing for harvest. There's a lot of applications of these technologies.
Now you have to compare this one to that one, and then we'll know which company is best.
There you go. And then we add some multispectral for a good measure, and yes. Does anyone have any questions for me? I'm sorry?
Is there a limit of airflow to
Uh,
run that?
Not in a hurricane. That's pretty much it. No, they're quite resilient. Yeah, they can take a beating. Excellent, excellent. Any other questions?
So, like, what's the uptake been in terms of across agriculture in Ontario? Are you run off your feet? Are you hiring more people? Are you just getting started? I don't mean to be offensive. I'm just interested in terms of how are people picking it up? Are they utilizing it? You had a couple of examples, but generally speaking.
Yes, that's a great question actually, and I do appreciate that, Peter. We're seeing it, if you put it in a curve, farmers themselves, there is a bit of a slower adoption curve, but we're starting. But bringing the message is we're seeing a better uptake now. Where we're seeing a larger uptake is with government organizations, with researchers. And these researchers are now more interested in large-scale data collection, but that also brings a really interesting opportunity because they're collecting the data, and yet the farmer is getting the benefit from it. So the farmer doesn't have to pay for the data, the government does, and they both get the benefit, right? The farmer gets the insights. We make sure that all the projects are very transparent and that we know exactly what the data is being used for. And then the research project brings as well a lot of really interesting insights. So for example, I'll give you one. We're working with the On-Farm project with the Ontario Soil and Crop Improvement Association, and we have flown fields all across the province, and this is all aimed at implementing better management practices at the farm based off this layer, like drone imagery, but then there's also satellite imagery, there is soil sampling, right?
So Lidar that you're collecting at the on-farm sites, or what
That-
type of information?
Multispectral in general to get an idea on different vegetation indices. Depending on the application, we use different vegetation indices. For example, the one that we use for that example with the AI, that one was chlorophyll index red edge.
Okay.
So we go a little bit deeper into that research part, and then based on that research, then we can get really deep and give very interesting insights to farmers. Yes.
You're flying there and you go over here. Do you have to have permission to do that against that one? Or can you go over and go anywhere you want, like trespassing?
Oh yeah, no. For example, yes. In theory, that's what they say. Of course, we always ask for permission to go into anyone's property. Although they say that the airspace is public. For example, satellite imagery. Like for example, you don't get satellite companies asking you whether they can image your fields, right? But for example, we do. If we go and we get our drones anywhere close to your farm, first we will need your authorization to say, yes, you can come in and then you can collect the data from here. So that is very important. And with drones, there's that stigma around privacy. So we have to be very, very careful and very respectful of the space of our clients. So yeah, there are real issues there, and it's very important that if you see a drone flying over your farm for any reason, you better make sure that you know the person that is flying it. You know, that is always very, very important. But the kind of information that you get, it's just great. All right.